This is the second episode of videos that I'm attempting to repair this external 5/4 inch floppy drive. In the last video I have repaired and tested the power supply, which is nice and functioning, very reliable. I can say that the test was very successfully, and I left the power supply itself to run for several hours with loads, and no issues has coming out. So for sure that is functioning. So it's time to give a look inside this drive and see if we can also repair that one. So let me remove the screws and pop up the upper shield. I've removed all the screws, and oh my god, really awesome, really awesome. Look at that. That's really incredible piece of equipment. Wow. Well, it looks like almost brand new, I have to say. So I don't think this is has been used a lot. It looks like a really low hour unit. So I already have seen two electrolytic capacitors, which I'm going to replace without even test. I will replace it directly, seeing the condition of the other on the power supply, on the others on that. So let me see if you can see on camera. Let me zoom in a bit, increase the light. Okay, so what I want to try to test is the strength required to turn the stepper motor. Oh, it's not really bad. It's not really bad. Well, for sure will require a bit of lubrication, but it's not really bad. Okay, so I removed some shields if I can, and get a nice lubrication and see if we can make some other mechanical test and lubrication, and then connect to the power supply. So let me first remove the shields. Okay, removing the top shield here has been a bit a challenge, since the upper head is in the way. So hopefully I didn't move anything. As always, I said, I'm not a computer expert. I'm just became a vintage computer fan, so I'm trying just to learn how should be traded. So just for curiosity, let's see the ICs that are on this board. So we have an Alps SC496, and the smaller one are 08. So this is an Alps controller, and this is an Hitachi HA1665. This is the other one, SMD chip. I'm not quite sure which is the purpose of those two. These appear to be the amplifier for the head. Let me zoom out a bit, sorry. Since I'm seeing trays that are going right to this, so it seems that this is an amplifier, and this should be the logic controller of the drive itself. So this is what seems to be logic. So actually feeling better it seems that it's a bit hard. Not really much, but it's a bit hard to move. It's a bit hard to move, not really free. So perhaps we have just to clean and lubricate a bit. The head, let's see if I can have a bit of more light and expose the heads. Not really. Let's see if I can show you a bit better. Sorry for the movement, it's not easy to manage these small items. However, they are really clean. Both heads are really clean. So let me tilt upside down, zoom out a bit. Well, actually this is a brand new condition. Look at that, it's very clean. It's really promising, I have to say. I strongly believe that this is a very low hour unit in terms of usage. Okay, so let me check more in depth a bit, and then I'll back with the results. Well, I've dismantled the drive since I want to replace actually 3 capacitors, and I don't want to leave that on the board. And then I've seen a lot of contamination on the input side of the disk right here, so I need to clean and polish a bit. Moreover, I want to give a good and nice clean on the front panel and the lever. So what I want to do is to prepare the metal parts first, and meanwhile I will clean and lubricate the head and head carriage, and after that I will go with the capacitor replacements. And right here I think this is a resistor array, which should be the termination of the drive itself. And I have noted just now that despite it is an IBM model, the manufacturer should be the Alps, as is stated right in the stickers in the back. So I'll go ahead with the cleaning and I'll back. All the parts are cleaned. The metal parts has given a good result. Actually, they looks like new. The same thing for this. I have replaced the capacitor on the boards, and they are a bit taller than the original one, but should not be a problem. The cleaning of the front bezel of the drive give a good result, so not too bad. And these are the amount of capacitors that I have replaced on this unit. Look at that. And one I have started to remove. One leg remained on the board, so it was damaged. And this is the tiny leg that remain on the board. So the unit, it's clean enough, it's good to me. I have polished a bit on this area, which is the input of the disk. So it's time to reassemble all the drive unit and make some starting test, since I don't want to give it a shock applying the full power after so long time that is off. It's clear a long time that is off because of the state of the electrolytic capacitor. So I will reassemble everything and I'll back on camera as soon as I will be ready. Everything is back together in this drive, so it's time to make some electrical test. As we can see exactly there, we have dual supply requirements as all the drives, and more precisely 5 volts and 12 volts. That's typical. So what I want to do right now is to apply a voltage that match what is written on the PCB, but I want to do it very slowly, and through this power supply, which is an analog power supply that I've used a lot of time also in other videos. So I'm going to switch on. I'm checking the voltage right now, limit to 11 milliamps, enabling the output. So what I want to do is rise up a bit and see the behavior. Okay, I'm seeing that the needle is already stopped, so it means that 11 millivolts, they are not enough. Let's try to rise a bit. Okay, still a bit more. However, we are around 50 to 100 milliamps. It's the needle is moving a bit, so I don't believe it's a matter of contact. I think there are electronic components that are trying to. Okay, so still need more current. So we are less than 200 milliamps. Let's see, 5 volts. Okay, let me reduce. 5 volts. Yes, 200 and a bit more. 220 maybe. Okay, but as you can see, it's jumping, and this is make me unhappy. So let's test the other rail and see the behavior. We are now on 12 volt rail, and I'm starting to increase voltage, and the current is to the minimum. So this rail actually seems to go to 11 volts and start to require a bit more current, but something that is irrelevant. So it's almost nothing, let's say around 20 milliamps. So I want to test more the other rail. Let me swap the alligators. Back on the 5 volt rail. And okay. Yes, we still are around 200 millivolts. And it's not jumping anymore, I have to say. So, time to apply the full power with its own power supply. Moment of truth number 1. So, yeah, really nice. Spot on 5 volts. So let me move on 12. That should be a bit lower if I remember well. Yes, but looks fine so far. So Yes, I think that is the point where normally we need to test this connected to a computer. So I will reassemble all the drive, and then in the next video I will try to make some tests with computer. So thanks for watching.